Hello, my name is Azal Saini, and from today I will tell a long story about SOC. What is SOC? SOC is the abbreviation of Security Operations Center, but why we should have SOC? Every company, organization, small or large enterprise that have data to protect, they should have a center to prevent data from stealing, sniffing, modifying, and deleting, and the like. The firms which are related to IT and network traffic have their own SOC center, but telecommunication companies are not usually familiar with this center, and they do not have their own deep secure structure to save their flows from data to signaling. Meanwhile, these companies need to equip their SOC center to monitor both logs of IT traffic and telecom messages. Therefore, telecom SOC would be more sophisticated than IT's. The steps that should be followed are: number one, we should familiar with all kinds of generation because we have all relative devices from 2G, 3G, 4G, 5G, and 6G in the near future that are working together. Then not only we should know the structure of each one separately, but also we should consider the related nodes or interactive connections between these generations. Number two, which nodes are really important to monitor in SOC Center? And number three, the logs of which interfaces have high priority. And number four, which is the relation between protocols, interfaces, and messages. Number five, the main brain of SOC and various SIMs to analyze traffic and messages. Number six, to parse the logs correctly, we should know the formats and the need to delineate explicitly. Number seven, in this level, we start a main function to discover useful features and isolate them to construct a good structure to responses that immediately. And number eight, every protocol has some features and significant paths which cause wide unknowns such as HLR. So how can we investigate principal footprints and alert as a suspicious behavior? And last, to make good dashboards based on famous known attack scenarios that are extracted from reliable references such as MITRE, GSMA, and so on. So, what is 2G? 2G generation was designed to carry voice and SMS in 1991 based on TDMA and CDMA modulation between 800 MHz to 900 MHz frequency. The speed of this generation is around 14.4 kilobits per second for downlink and uplink. You should know then what's downlink or uplink. Downlink means while you want to download something and receive data from satellite, and uplink means you want to upload something. In fact, you send data to satellite. In other words, the communication going from a satellite to ground is called downlink, and when it is going from ground to satellite, it is called uplink. Okay, 2G or GSM network had 37.5 centimeter long. That means a 37.5 long antenna. That was around half of a meter in theory. Yes, this presumption was really long. After almost 3 years, in 1993, the structure of core network was modified from circuit switching to packet switching. Don't forget this abbreviation: PS and PS for packet switching and CS for circuit switching. With GPRS modems and IP added to routing packets or messages to internet, and the speed was enhanced to 53.6 kilobits per second for downlink and around 27 kilobits per second for uplink. Okay, after then on, in 2003, 8 PSK encoding modulation was perfect. It was preferred because this kind of modulation can improve our speed to 236.8 kilobits per second for downlink and around 60 kilobits per second for uplink. Okay, let me back to main picture. In this image, we have 4 sections. Number 1, number 2, number 3, and number 4. What are these? First of all, section number 1 that involves mobile device and SIM card that can identify the owner in internal connection by MS-ISDN number and international connection by IMSI number, which can be spelled MC. So, the section number 2 is about BSS. But what's this? A specialization subsystem. Indeed, it has many BTSs. You can see, for example, in this picture, we have 2 BTS and 1 BSC. It has many in this section. We can imagine that many BTS antennas and a fewer BSC center that manage BTSs by ABs interfaces. So how can we send our signals to core network that might be CS or PS? What are these? Circuit switching and packet switching for connecting BSC to MSC. But what's MSC? MSC is a mobile switching center. We need A-links to connect BSC at the end of this node to MSC. But actually we can say that A-link can connect BSS to MSC. Actually, A-links transfer data and signaling from BSS module to MSC, then to probe some details of subscribers' information and interconnect with a VLR, visitor location register, that can be visible by B-link. This link supports messages of MAP protocol in SS7 stack protocol. Then what is VLR or MSC? MSC is a model center to connect nodes to each other, and after these years is equipped by various abilities that manage signals upon connect different nodes to each other. That is VLR. VLR is a server in a cellular network that supports roaming functions for users outside the coverage area of their own HLR. You can suppose that we have two networks, internal network and roaming network. For roaming network, we need some VLRs to connect ourselves to home network that we belong to it. Let me explain more about section 3. Yes, section. As an OSS, that means network subsystem, and includes MSC, VLR, HLR, EIR, AUC, OMC, and internal nodes to fasten and transfer data among core network. But what's OMC? OMC is a manager to do authentication functionality in GSM network. AUC and EIR and HLR, these three sectors are the different databases for safe subscribers data, and registration code to encryption algorithms. And with the C-Link. C interface, you can see that map protocol on C-Link for connecting HLR to Gateway MSC. This abbreviation is the gateway that can be connected for MSC to the outer core network. And sending data to out of core network, for example, to the internet, to ISDN network, which can be used today, DSL or ADSL modems, and telephone network. What are A, B, C, and D link? They refers to the SS7 infrastructure, and if we want to compare these nodes to the IT network, we can use switch instead of SSP, router instead of STP, and DB instead of SCP. So in this picture, we have three kinds of nodes. SSP, that we can say two switches. For STPs, that means for routers, to sending messages that are related to the interfaces B, A, and D, and C, and one DB SCP that can play a role as a database in SS7 network. So we can discuss about these links moreover in next slide. What are SS7 interfaces? Signaling data links has 6 different kinds: access link A, bridge links B, cross link C, diagonal link D, and extended link E. Fully associated link is F. But what's A? For connecting SSP to STP or SCP to STP. What are these? SSP, we discussed about them. SSP was switch and SCP was DB, database. But what's B? B is for connecting two STPs in the same hierarchical level. And C to maintain redundancy. And D-Link, what's the difference between D and B? D is connected to STPs, but from one layer to another level of hierarchy. Extended links to connect SSPs, switches to STPs, to routers remotely. And F, to route large number of traffic between SSPs. When we have two main switches that wants to transfer data, they should need F-Link for connecting and transferring these kinds of data. What is SCP node? We discussed about this node. It's a kind of database, but how many databases do we have in SS7 network? We have 6 kinds. Call management service database, local number portability, line information database, business service database, and 2 famous nodes that we discussed in previous section, which are home location register HLR and visitors location register. We discussed about the difference between these two kinds of node. HLR is working in home network and VLR is working in visitors. When you travel to another country and you want to connect to your home network, you should use VLR to verify your cause identification to your home network and connect with your relationships.